So we already mentioned that statistics requires a lot of critical thinking. And in this next section, section 2, we're going to talk about some of those ideas. The first part of statistics is have to prepare. And even if we're looking at data that's already been collected for us, we need to be aware of the context of the data. How was the data collected? Because that could give some reason or way that we interpret it. Let's see, what's the goal of the study? What is it that we're trying to find out? And if we're given a set of data, then we might be asked those questions. You know, how was the data collected? And in particular, with these particular variables, what can we answer about the study? Okay, the next thing is the source of the data. Are the data from a source with a special interest so that there is pressure to obtain results that are favorable to the source? Okay, sometimes depending on the source, you know, if I don't know, if I'm the orange juice consortium or whatever, and I want to say that orange juice helps people when they have a cold, and I pay to support a survey, then the results of that survey could benefit me, right? People go out and buy more orange juice. So we need to consider the source of the data. We want the source of the data to be unbiased. And there are lots of things out there. How many people have heard of a Gallup poll? Anybody? Okay, well, you'll hear a lot about it because there are lots of examples in the book that talk about the Gallup poll. That's pretty much an independent agency that collects data. Another one would be maybe Nielsen ratings. Okay, they collect a lot of data about what people watch on TV. So they're an independent agency. Or something like Consumer Reports. They don't have really a reason, as far as we know, to support one product over another. They're independent. And so they would not be a source of bias, but some other things might be. And then we want to talk about the sampling method, where the data collected in a way that is unbiased, or where the data collected in a way that is biased, such as a procedure in which respondents volunteer to participate. Okay? So we already talked about the voluntary response sample, or this is what I mentioned earlier as our self-selected survey. Okay, and this is one where participants choose or self-select to participate. Okay, and we've already talked a little bit about how that can be dangerous. Where are some places where we might see these voluntary or self-selected surveys? We talked about one earlier. What'd you say? Okay, a comment card. That's a good one. I hadn't even thought about that. What's that? Health products? Well, but are those people self-selected? We're talking about where people could choose to participate in this case. Yeah, but where's the survey? And where can we choose to participate in it? And I think we're talking more generally at this point, like, for instance, as they just said, an online source. Okay, you see surveys all the time in your email. Okay, also mail in. We talked about that already in an earlier example. You can do a mail-in survey. And then the last one is mail-in, online, and telephone. All very dangerous, okay? Especially if there's a cost involved, okay? Now here's where you might see this kind of self-selected thing related to toothpaste. Let's say there's a survey out there and it says, should you use your toothpaste from the end, or is it okay to squeeze it in the middle? And you got to pay $2 or $3 per minute to express your views. How many of you would make the call at $2 or $3 a minute? Nobody? Okay, you don't feel strongly enough about that, right? What's something that you might feel strongly enough about? Okay, ask me if community college teachers are overpaid. I'm probably calling in. Okay, or something like, everybody's got that little issue, that short button issue that you might, pay, right, to express your views. But what happens in that case? What kind of responses do we get? Bias, and very extreme. People feel very strongly one way or the other if they're going to pay to participate in the survey. Okay, so that's very dangerous. I haven't seen any surveys like that recently. Mail-in surveys, you see those all the time. Online surveys, they come to you in the mail all the time. And this one I had not thought about, but I think it's very good, a comment card. If you go to a restaurant or a store and you have a very good experience or a very bad experience, then people, might respond. Same thing at the end of the semester with the teacher surveys, class surveys, course evaluations. Usually those are very extreme. You don't get anybody who say, it was all right. It's just like I either loved it or I hated it. Okay, so I want you to take some time and think again through the next 3 examples regarding sampling methods, whether or not there appears to be some flaw, and then the next one just asks you outright what is wrong with the survey. Okay, we want to determine whether the sampling method appears to be sound or is flawed. And it says in a survey of 109 subjects, each was asked to indicate how many text messages they send and receive each day. The sample consisted of those who chose to respond to the request posted on the StatCrunch website. Okay, and I probably should tell you, StatCrunch is a website related to the text, to this particular publisher. All right, so what do you think? Is this flawed? Okay, what might be some reasons that you say that this is flawed? Okay, so that self-selected survey. All right, any other things that would there be any bias here? Okay. Okay. Well, definitely, if this is related to our particular publisher, it would be 18 and above. That's still a pretty wide range. But if they were talking about anybody who had a cell phone, then they've missed younger people. Okay, so there definitely could be some bias. It depends on what their target population was. Okay, very good. We'll just say possible bias. Anything else that might cause bias here? I mean, there are lots of things. We could go on and on, but if we're talking about StatCrunch related to our textbook, then what population of people are we talking about in general? Students, college students. And so, maybe there's some habits with college students in texting that don't exist in the general population. We don't know. Okay, we'd have to do a study on that to find out. Very good. And B, in a survey of beliefs about evolution, Gallup pollsters randomly selected and telephoned 1,018 adults in the United States. Does this appear to be sound, or is it flawed? Okay, it appears to be sound. What's the assumption, though? Not necessarily everybody responded. Can we reach everybody by telephone? Not everybody has a telephone. But almost everybody does, I guess. I don't know. There was a time when this would definitely be a flaw. In 2013, is it still a flaw? I don't know. I'll tell you that the author did say that there was no flaw here. This was unbiased. But in the back of my head, I'm thinking about whether or not people have telephones. Okay. All right, very good. The next one, a survey sponsored by the American Laser Center included responses from 575 adults, and 24% of the respondents said that the face is their favorite body part. What's wrong with this survey? Lots of bias, okay? Or would you say? Sponsor bias. That's exactly right. Sponsor bias. I mean, the Laser Center, they've got, they'll benefit by saying, yeah, people think your face is the most important thing. So that might cause people to go out and spend extra money on what? Their face. Okay, so sponsor bias. Excellent. Okay, any questions about that? And the same kinds of questions that we're going over here in class, those are the types of things that you'll see on the test. Okay, so this is what I think is really, really, really important, what we're talking about here. Okay, so another thing, after we've prepared our data, we've thought about the context and the source and all of that, then we'll be talking in detail about graphing data. We'll explore our data by looking at statistics such as the mean, standard deviation, and those things that help us understand our data. We'll talk about how our data is distributed. Are there missing data? Did many selected subjects refuse to respond? Okay, that's something to think about. When people choose not to respond, even if you've kind of randomly selected, you've got these people, but they choose not to respond, what is it about that particular subgroup that might cause them not to respond? Okay, and then we'll apply statistical methods, mostly using our technology. By the way, I forgot to mention calculator. You need to get the TI-84 calculator. I mentioned it in the video and the other stuff, but we will be using this. Data sets can be very, very large. So at this point, it's really impractical to talk about statistics without also talking about technology. So we'll be doing a lot of critical thinking, but we'll let our calculator do all the number crunching. So make sure you have an 84, 83, maybe 82 calculator. Okay, preferably the 84. All right, but we'll apply the statistical methods using our fancy calculators. All right, so when we're analyzing data, there's several areas of potential pitfall that we want to consider. First of all, we want to talk about misleading conclusions, especially when results a lot from when we have a sample that doesn't represent our population. Okay, so often we get misleading conclusions. We'll talk a little bit later about what's the word? Lurking variables. Okay, where it seems that one variable has an influence on another, but actually there's something in between them that connects the two. For instance, the author had a very good example. He talked about the increase of ice cream consumption and the number of swimming accidents, that those things were correlated. Do you think that eating more ice cream causes people to have swimming accidents? No. Okay. What's the thing that connects those two that probably has the influence on both of them? Summer, or we might say temperature, right? The hotter it gets, the more ice cream people eat, and then the more people swim, and possibly that could lead to accidents. So that's what we call a lurking variable. So we don't want to make misleading conclusions, all right? Even though our calculator will do a lot of stuff for us, we still have to think about, does this make sense? Okay, reported results. A really important one. When we collect data, there's a huge difference between asking people to report values and actually getting those values. I mean, prime example, weight. If you ask most people how much they weigh, they're going to take off a few pounds, right? Okay, versus if you put a person on a scale, that's an entirely different story. Okay, so reported results. When we collect data, sometimes we can't help reported results. That's the only way you can get the data. But if you can help it, it's better to collect data yourself instead of relying on people to report results, because they tend to, make themselves look a little better than possibly they are. Okay, small samples, right? When we want to make an inference about a population, there's really no hard and fast rule that we'll use about how many people have to be in the sample. But if you've got, 12,000 students here at Midlands Tech, you need to sample more than 5 if you want to know, how students feel about programs here at the college, right? We've got to have a sample that's large enough for us to get feelings or opinions about the college. Loaded questions. Here's an example of a loaded question. Do you support the development of weapons that could kill millions of innocent people? How many people can say yes to that question? Okay, we got one. But what's the problem there? Who wants to kill millions of innocent people? That's a loaded question, right? Nobody. Most people aren't going to say yes to that. Do we think that countries should develop weapons? Yes. Even that's hard for me to say yes to. Yes. That's a separate question. Whether or not potentially they can kill millions of people, I don't need that pressure when I'm trying to answer that question. That's a loaded question. Okay, the question was, do you support the development of weapons that could kill millions of innocent people? Okay, we want to avoid loaded questions. The order of questions. The order of questions makes a huge difference, and I posted in Desire to Learn a link to an article that talks about it. It's a very short article or whatever, but in that particular article, they were doing a comment kind of thing after a person had eaten at a restaurant, and one of the first questions was about the temperature of the food. Okay, now, how important do you think temperature of food is in your experience when you eat? Very important, okay? So it doesn't matter if your food came to the table cold, but your waitress or waiter was the nicest person ever. How do you think the rest of the questions are going to be answered? Positively or negatively? Negatively. That's what they call the halo effect. That first question, how you responded to it, influenced how other questions were answered. So, they talk about some guidelines if you were doing a survey on what you should do so that you can avoid kind of that order bias. If possible, it's a good idea to randomize the order of questions, or start with things that are more general and then come down to those things that are very specific. Even in something like a taste test, order matters. One of the projects that students have done in the past, this has been years ago now. This is my 18th year here. I can't believe it. But, a long time ago, students would do taste tests. I approve stuff like that. I wouldn't taste stuff these days. But if they were trying to determine whether people could tell the difference between Pepsi and Coke, or not really tell the difference, but truly had a preference when it was a blind test, you can't give Pepsi first every time. You need to mix it up. Give Coke first sometimes, give Pepsi first sometimes. Otherwise, everything's being judged based on Pepsi, right? Okay, so that's another time where we might rearrange the order of our questions, or the order of the process. Non-response. Why are people choosing not to respond? We talked about that already. One case in particular where people might not respond is in income situations. Okay, depending on what it's asking or whatever, where it is. Someone's asking about your income, then you might choose not to give that information. Okay, non-response. Missing data. Sometimes people fall out of studies. Is there a pattern to that? almost the same thing as non-response, but we need to think about the effect that missing data might have on our particular study. Precise numbers. If someone reports that we've got 12,676 students here at Midlands Tech this semester, that sounds very precise, but it's not necessarily accurate. It's better for me to say, as I've been saying today, about 12,000 students, because I really don't know. But sometimes people, some of these things people do intentionally. People will do these things to mislead you, to make it look as if they know what they're talking about and they really don't. Okay, so precise numbers. Is that the real number? You know, does the person have the ability to know that's the real number, or is that a number they just put out there? And then finally, percentages. We're going to look at some exercises in just a second regarding percentages, but you want to make sure that when you're looking at percentages, sometimes it's really helpful to do the calculation and figure out what the real number is, because percentages can be very influencing if you don't actually do the calculations, especially when you start talking about percentages of percentages. Okay, let's say 37% of students at Midlands Tech preferred the bookstore. Of that 37%, 2% say that the bookstore prices are too expensive. Well, what's 37% times 2% times the 12,000 that we've been talking about? Okay, so sometimes it helps to do calculations. All right. And then finally, we want to talk about conclusions and statistical and practical significance. Okay, practical significance is pretty easy. With practical significance, it's just at the end of the day, was it worth it? Does it really make a difference? That's what practical significance is. Statistical significance talks about, are these results different from what we're able to get by chance? Okay, statistical significance presents results that we would not have gotten by chance, that were not likely by chance. Let me write that down. Okay. All right. So let's look at some examples and see if we can figure a little more. Come on. Okay, in a study of the gender aid method of gender selection, 1,000 users of the method gave birth to 540 boys and 460 girls. There is about a 1% chance that such extreme results would occur if the method had no effect. Okay, so the question, did I type a question? The question is there statistical significance? Is there significance? Okay, in this case, we would say, yes, there's statistical significance. Okay, because they're telling us that we get these results only by 1% chance if there's no effect. If the probability of getting a boy versus a girl is exactly 50%, then we would get these particular results about 1% of the time. 1% is so small, and then here we are with the results. Since we've got the results in our hand, we assume that it's more likely than just the 1%. Does that make sense? Because that's an idea that we'll talk about a lot. If I've got something in my hand, some results in my hand, I pretty much assume those results are not unusual because I'm holding them right here. Does that make sense? Okay. So if I've got them in my hand, then apparently it's more than just this 1%. All right. So we would say in this case that there is statistical significance. Everybody understand that? Okay. But is there practical significance? Is there practical significance? How much do we think this costs? A lot, okay? And at a lot, would you be willing to pay whatever that is for these types of results? Instead of 50% boys, 50% girls, we're going to move it up to 54% boys and 46% girls. No, okay? It's not practically significant. It's not that different from 50-50 chance. So we're going to say no, this is not practically significant. All right, do you see the difference? Yes, no? At the practical means, does it really make a difference? Just kind of bottom line. All right? And so, like I said, I mean, assuming that boys and girls are equally likely to be conceived, 50% boys, 50% girls. Here we're looking at a situation where you could get a chance of 54% boys. But you got to pay a lot of money for that. All right, for the cost, is it practical? Okay, no, it's not practical. So it says not practically significant. Okay, here's another example. One of Gregor Mendel's famous hybridization experiments with peas yielded 580 offspring, with 152 of those peas having yellow pods. According to Mendel's theory, 25% of the offspring peas should have yellow pods. Do the results of the experiment differ from Mendel's claim rate of 25% by an amount that is statistically significant? No. Should we call the paper because, you know, he got 26% when in theory he should have gotten 25? No. Okay, it's not statistically significant. Not that big of a difference. Okay. And then was there another question about this? Okay, good. Okay. All right, here's some more on analyzing data. When we look at data, this kind of leads us through some questions we should consider. Suppose I gave you this set of data. It says, refer to the table of pulse rates. Is there some meaningful way in which each male pulse rate is matched with the corresponding female pulse rate? Is it something about the arrangement of this data such that I don't want to swap around the female values without keeping them tied to those male values? No. Okay, without knowing anything else about it, we have no reason to think that the male pulse rate would be tied to the female pulse rate. Okay, so we're going to say no, there's really no meaningful way. If the male pulse rates and female pulse rates are not matched, does it make sense to use the difference between any of the pulse rates in the same column? No, doesn't make sense. Okay, so when you're looking at data, you know, just kind of think about some of those things. What could I do with this? What makes sense? Okay, in this next one, or actually same data set, the listed pulse rates were obtained for the 3rd National Health and Nutrition Examination Survey conducted by the U.S. Department of Health and Human Services, National Center for Health Statistics. Is the source of the data likely to be unbiased? Yes, we think so. Okay, it sounds like it's an official place, unbiased. You know, they're not going to get anything that helps them with pulse rates. So we'll say yes. Okay. All right, what about this next one? Refer to the given table of IQ scores and brain volumes. Is there some meaningful way in which the IQ scores are matched with the corresponding brain volumes? If they are matched, does it make sense to use the difference between each IQ score and the brain volume that's in the same column? Okay, that makes sense, right? For one person, if we're interested, someone might have a question about, the volume of your brain and your IQ. So we might measure both of those things, if possible, on an individual. So we want to keep these numbers tied together because each column refers to a particular subject. Okay, so the question was, is there some meaningful way in which these things correspond? We would say yes. Okay, each column is for a particular individual. Do we think we should subtract these things? Would it be meaningful for us to subtract the IQ score from the brain volume? No, probably not. Okay, in fact, no, period. It wouldn't be meaningful at all. All right, given the context of the data, what issue can be addressed by conducting a statistical analysis of the measurements? And I think I already mentioned that. We could ask, is there a relationship between IQ and brain volume? Okay, that's what we could ask. All right, and we could use statistics to answer that question. The question at the bottom here was, given the context of the data, which issue or what issue can be addressed by conducting a statistical analysis of the measurements? And I said, is there a correlation between brain volume and IQ? Okay. All right, if we were to use such data and conclude that there is a correlation or association between IQ score and brain volume, does it follow that larger brains are the case of higher IQ scores? No. Okay, that's what we call correlation and causation. Okay, there can be a correlation between items, but that doesn't mean one causes the other. Okay, and we'll talk a little bit more about that, but you want to be careful about assuming that correlation leads to some causation. Okay, alrighty, I think we'll stop there for today. When you come next time,